I will now show you how to pass arrays to functions so that functions can use variables stored in arrays and also modify these. To that end, I've started here with a little main program in which I simply have our show memory command that is codecast specific. And then I declared an array and it has 6 elements, and I just put some random stuff in there, 6, 2, -4, 8, 5, 1, some integers. And I have a second variable here that holds the number of elements in the array. We have learned that the variable array itself holds the address of where the array starts, which is the address of array of 0. An array does not know its own size in C. That's why we need to keep track of the size by ourselves. Suppose first that we wanted to write a function that prints the array. So why don't we call that print array? So to it, we need to pass the pointer array that shows where the array starts in memory, but we also need to pass to it the size of the array, because otherwise the print array function will not know how many elements are stored in the array, because the array itself does not know its size. So this function doesn't return anything. Its only job is to print the elements of the array. So it has a return type of void, is the function name, and array itself is a pointer to an integer. So an integer pointer, and let's call it PTR down here. It's the pointer, it's the address of where array starts. And the number that we're passing in is simply an integer, and that's called that size. How does this function work? This function will go in a loop, ideally, through all the elements of the array, because we don't know how many of those there are, and print them out. So we need an integer I, for example, as a loop counter, and then we can write a for loop for I from 0 while I is less than size, I++. So this is meant to loop through all the elements of the array. And now we want to print out. So we want to printf. We want to print an integer because the array stores integers, and then maybe a space next to it. And what is it we want to print? We want to print what's at location I in the array. PTR itself points to the beginning of the array. It's the address of array of 0. We want to print out what's stored at location I. PTR plus I points to that location. So this is the address of what's stored at the ith location. In order to print the contents that's stored at that address, we need to dereference. So we dereference PTR plus I, and that will print out what's stored at that location. Now we just close our parentheses and put a semicolon in there, and that's about it. How about in the end, we also print a \n so we can start a new line. Let's try this out. In order to do so, we need to put a prototype at the top of our program. I left some space here for exactly that purpose. We could leave our names of variables in there, or we just change it to simply the data types themselves. Let's compile and run this program step by step. First, our array is declared and initialized, and there it shows up in memory. Then n is declared and initialized as 6. There it is. And now the function print array is called. We're passing to it array, which is the address of where the array starts. So it's FFE8 in this memory visualization. And you can see that a new variable showed up here in my memory strip, PTR, and indeed it stores FFE8, which is the address of array. Array starts at FFE8. And then size is another variable that lives in this function print array, and it has the value 6 that was passed into it, so a copy of what was stored in n. Let's go one step further. We're entering our loop. Initially, I is 0. That is less than our size, which is 6. And therefore, we enter the for loop, and we print out with a %d star PTR plus I. I is 0, so we're simply dereferencing PTR. PTR has the address of array of 0 stored in it. When we dereference that, we gain the 6 that is stored in an array of 0. You can see that we're reading what's stored in an array of 0, and we just print it out as 6. Next, I is increased by 1. 1 is still less than 6, which is the size of the array. And now we're going to print what's stored at location PTR plus 1. PTR pointed to array of 0, so PTR plus 1 is going to point to where array of 1 is stored. And by dereferencing that, we gain access to the 2 that's stored in an array of 1. And there it is, we printed the 2. And now you can see how this continues on. I is increased to 2. We're printing out the dereferenced pointer PTR plus 2, which is an array of 2 where negative 4 is stored. So we're printing out that negative 4, I is increased. And we keep going like that until I reaches its final value 6 and the program terminates. All right, let's now do something slightly different. I want to show you another way of writing this dereferenced PTR plus I. That looks somewhat confusing. PTR plus I points to the ith element of the array, and then we need to dereference. There's an alternative way of doing the same thing. I'm going to copy this line, put a comment in front of this line, and put it in there again. And now instead of star PTR plus I, we could actually use array notation here. We could treat PTR as if it were an array of integers and simply write PTR of I. Well, that looks much easier than star PTR plus I. And it's the same thing. Pointer arithmetic makes it possible for us to use array notation, even though all we received here was an integer pointer. To demonstrate that this is really so, I'll run this program one more time. Go through, I'm in the print array function now. I is equal to 0. So we enter the for loop, and we're printing PTR of 0, which is the same as array of 0, since PTR and array both point to the same location, namely FFE8. So the 6 got printed out. In the next round, we print out array of 1. PTR of 1 and array of 1 are the same. And then PTR of 2 and array of 2 are the same. PTR of 3 is the same address, has the same address as array of 3, and so forth. So that notation might be much easier for you to understand than the star PTR plus I notation, but they are really the same. All right, now let's write another function that actually changes the values that are stored in the array. Suppose we wanted to square the value stored in the array. So we'll just call that square array. And again, what do we need? We need to pass the array to the function. And since an array is already an address, we don't need to put an extra ampersand in front of that like we normally have to do if we want the function to change the value of a variable. For arrays, we pass the array itself, which already is an address. And again, we need the size, and that's all we need. So now let's write this new function, square array. It doesn't return anything, so the return type is void again. Here's the name. And we're passing in the array, so it's a pointer to an integer. We'll call it PTR again, and again, the size, we'll call it size. So what do we want to do in here? We want to simply square each element of the array. So we want to go write a for loop. So we need a loop counter, int I, and then we can write a for loop for I from 0, I less than size, I plus plus. And we want to take the element that's stored at location I. We just learned we can simply address that as PTR of I rather than having to write star PTR plus I. And what do we want to do with that? We want to update that with a square of what used to be stored there. So we want to take PTR of I and multiply it by PTR of I. And that's it. So that's how simple this line looks if we use the array notation. If we wanted to use the pointer notation to equivalently, we could have also written star PTR plus I, which takes the pointer PTR, which points to array of 0, adds I to it, which makes it point to array of I, and dereference the stat. So it gets us also to what's stored at array of I, just like PTR of I does. And then we need to take that PTR plus I and now multiply it by itself. So I'm going to put some extra parentheses around here to make this look less confusing. Times, and then one more time, opening parentheses, star PTR plus I. So this looks kind of confusing, but it's really the same thing. So now that we squared the array, we should probably print it out one more time to make sure we actually squared it correctly. So we simply call print array one more time, just as we called it before, and it should print out the squared array. The final thing we need is our prototype. So I'll simply copy this line and paste it in here with a semicolon behind and get rid of the variable names. I could have left them there if I would have wanted to. And we are ready to go. Let's compile and run this step by step. The array is declared. I'm going to step through these steps rather quickly because we already did the printing before. So we're printing all the elements of the array. And now we are getting to the square array function. We're calling the function square array, and you see in memory a variable PTR showed up that holds the address of array of 0, so the address where array starts, and size is a variable that showed up and it has the value 6. In the next step, I is declared, so now we also have a variable I, and currently it does not have a reasonable value yet because we haven't initialized it yet, but now that we initialize it with 0, it has a good value. We're checking whether it is less than 6. That is indeed the case. And we're getting to this line, PTR of I is PTR of I times PTR of I. PTR of I is the same as array of I. I is 0, so we're simply taking the value 6, which is stored at array of 0, multiplying it by itself, that's 36, and then replacing the 6 with a 36. And that's indeed what just happened. Array of 0 now holds a 36. Next, I is increased. I now has the value 1. And we again enter the loop, and we're modifying array of 1, which is the same as PTR of 1, because PTR and array point to the same location in memory. So array of 1 is 2. 2 times 2 equals 4, so watch what happens to array of 1. Array of 1 is replaced with a 4. Similarly, array of 2 is next replaced with -4 times -4, which is 16. Then array of 3 is replaced with a 64. Next, array of 4 is replaced, and I need to scroll so you can actually see it, replaced with 25. And finally, array of 5 is 1 times 1, so that's replaced with a 1, which you can't see. I is finally large enough to exit the loop, and we get back to the print array function. So we're back in the main function, and all the variables that just existed are gone. All the variables from square array are gone. Only the variables from our main function are left. Now we enter print array, and new variables show up. I have a PTR again, which holds the address of array of 0, and I have a size in there, which has the value 6. I is declared, initialized, and we again go through the printing, and all these squared numbers are printed out as they did before. So this is how you print and modify arrays using functions. Again, this is different. Modifying arrays using functions or passing arrays to functions is a little bit different from passing regular variables because array itself is already an address. So there's no need to get the address of array because it already is an address. And so that's a little bit different than for regular variables. Again, play so that you can get used to these new concepts.